Today we'll be taking a look at the upgraded dishwasher door for my Danby dishwasher. The newer models don't actually have a window. I kind of think it's nifty. You can see it running while it's running. The door actually disassembles really easily. You can unscrew these things using a wrench. You need a very large adjustable wrench, and then there's just a few screws to take it apart. And you don't even have to remove these screws, it's just the other ones. And you can take the door off. That part's pretty easy. I won't be going over any of that in this video. However, I will go over the replacement. This is a polycarbonate piece of polycarbonate that I purchased here, and it is actually a lot more rigid than the original. We're going to look at the original, we'll see what's wrong with the original. We'll go over every aspect of this, including the gaskets for the watertight seal. And you notice now when you're loading it and unloading it, any stresses on the door shouldn't disrupt this. I don't think I'll have to replace it for quite some time now. Because the gasket was still intact. So I had the original gasket. That's what really made this possible. So without further ado, I'm going to dive into a couple other details here. So here's the old door, you'll see. My first idea for replacing it was to actually just cut it out of a piece of Rubbermaid number 5 polypropylene. But this wasn't not the right size, and also I'm not sure, like, while these are heat resistant, polycarbonate is probably better. I actually just purchased a piece of plexiglass. I don't think you should use plexiglass, but mostly because I don't really know what's in it. Don't know how well it'll hold up to the heat. I mean, it should be pretty stable, but it's not really exactly food grade. Polycarbonate, I think, is probably the best choice. At least that's what I decided on. It comes in a slightly thicker sheet where I purchased it, but it worked pretty good. Obviously it stinks really bad when you cut it, so you need a really well ventilated place to cut it. I'm not even sure there is a way to contain all the nasty particulate fumes and things like that, but I used a shop vac and a table saw ultimately. And you'll see I've traced the angle. This shows how I did it when I cut the other one. So I traced the angle, took a number of cuts to approximate the curvature to get basically the correct size. So, if this is intact, you don't actually really need to replace it. What I did in my first repair, which was not videotaped, however, it was a repair, is I used these little wood screws, and I came through the steel from the other end, and it just threaded right in. So, the original design had little plastic nubs that would stick out, each of these, and those nubs went through the steel sheet, and then they were kind of melted over on the other side. So those little pieces of plastic originally broke on me, and it messed up the watertight seal. So there was a gasket that goes in this groove, which I repurposed. The gasket was still in good shape. It was just the fact that those little nubs broke originally. So my first repair, I tried to screw the steel sheet on, and then I cut off the excess from the screw. However, I may have over tightened some of them because it started to crack, and eventually got even worse and was more leaky than, or even when it had started. So I had to come up with another repair. So I replaced it with the polycarbonate. So far so good with that. I'm really happy with that. If you were to try to repair using the original, if yours is in good shape, I would recommend not using this approach, but to instead just bolt it together using a locking nut and a gasket to achieve a good seal. I'll show the gaskets I bought later. Ultimately used number 8 screws that were 1/2 inch. You can see they're all disappeared. These are 3/4 of an inch, and these are the locking nuts that go on the number 8s. It kind of makes it easy to assemble. What I ultimately did is I drilled holes and I countersunk those holes, and then I used the gaskets in the countersunk hole. I don't necessarily recommend that. I don't think you need to countersink it, except if you want to use 1/2 inch screws. I used stainless steel hardware, number 8s. Ultimately 1/2 inch screws were the right size, locking nuts that worked with the number 8s. They're also stainless steel. Do some more research about polycarbonate. You'll notice it has a very high working temperature over the boiling point by at least a little bit, which is important for this application. It's probably not BPA free, if I recall correctly, so you can probably do your own research if you're concerned about that, but I don't think very much of that is going to leach off in the dishwasher. It's going to be less and less over time too, probably, as it does get continually rinsed. Also, there's probably other sources of BPA that I would be more worried about. But you know, you could always actually use something non-transparent. You could even try to use glass if you could cut it. I would have definitely used glass. I prefer glass, but I just don't think I could have bolted it in there and kept it in one piece. Maybe someone else knows more about this than I do and can recommend a better plastic to use, but I've had really good results with the polycarbonate. I've been using the dishwasher for at least 4 months now since I fixed it, so I'm pretty satisfied with the repair. Where I found the polycarbonate sheet on eBay, I got the 12 by 12, so 1 square foot piece of it, pre-cut. It was great. I only had to cut it down a little bit and around the corners, so it definitely was a nice size and thickness sheet to work with for this project. Make special drill bits for countersinking plastic. I just use regular wood bits to perform the countersinking. You might not really need to countersink anything, but it does help to get the screw heads to sit flush with the surface if it is countersunk. The only tricky thing about countersinking is that your rubber gaskets might not seat properly in the countersunk hole. 1 or 2 of the ones, if I had over tightened it or wasn't careful tightening it, it wouldn't seal right. So you kind of just have to be careful. All those little rubber O-rings, which are heat resistant, by the way, they also come in slight variations of size. So you just have to be really careful when installing those, not to over tighten them. But the large gasket was always intact. So that's the other thing, is maintaining that the large gasket's condition and quality, otherwise you won't have a watertight seal. So here's the model dishwasher that it is. There's the newer ones without the window that you can use instead. If you were to buy it today, you'd probably end up with a new one. If you're buying an old one, chances are the seal in the door might have issues, but it does depend on how much stress is applied to the door, how heavy the dishes were that are loaded onto the door, and how unevenly they're loaded. So there's actually dual windows. There's a window that's part of the front piece of the door, and then there's the actual watertight window that's part of the steel inner door. So that's what we actually replaced. This model is really nice. It has several different modes. Let's see if we can find the information about that. Here we go. So it's got the intensive wash with P1. It actually has a built-in heater. 125 minutes. This black bar is supposed to be up here. I don't know what's going on with that PDF rendering. P2 is the default mode. Shows the temperatures here. It's well below boiling. It's so much below boiling. But we generally use P3, which is just the hot water out of the tap temperature. I mean, I don't know how they can even give us a temperature, but the heater doesn't run on P3, so it does save a little energy. At least that's my understanding. Although there's the economy wash too, which is actually a longer cycle, and interestingly looks like it has a heated rinse, if I'm looking at this correctly. That's the hottest rinse of all. Let's see what's under this. No, it's the same as the P1 rinse, so that's interesting. In any case, P5 is just a rinse cycle. So typically I pre-wash the dishes, and really all I'm trying to do is avoid wasting water during the rinse. So really all I need is P5, but I usually just run it through P3 and add a tiny bit of dish soap to the cycle, just in case I miss something during the pre-wash. So that should just about pad this video out to 10 minutes. Not sure why I am doing that, but you know, just in case my channel ever gets monetized again. I hear that in this day and age, it's really good to have 10-minute videos, if you haven't already heard that a million times by now. So yeah, when you first turn it on, it'll pump out all the water that's in the bottom, and then it'll start. And we don't use a rinse agent typically. We only put a little bit of soap in it. I'm ultimately pretty happy with the purchase. I made it a while ago, and this thing's still useful. It does take up some space on your counter, and it also barely fits underneath our kitchen counters. I guess I could get you a measurement on that. So the height's about 17 inches. So like our counter's a little bit taller than that. Also, I've put little feet under the dishwasher. I took the caps off of some, what are they? They're like those Tetra Pak containers where you get chicken stock and things like that. So the Tetra Pak lids make excellent feet for this. Also, some things in the setup, like the drain hose should be level so that it drains good, so there's just no bubble in the hose. So we use little, those ketchup packets are great engineering. They help to line the drain hose properly. I'll show that at some point in a different video probably. Well, I think that's about it.